we're going to talk about what happens if we take those sections that in the previous section 6.1 we were finding the area of, and now instead of finding the area of, we're going to take those shapes, rotate them around the x or y axis, sometimes another line, and find out the volume of our now three-dimensional figure. So, to do that, it's kind of like one of these party decorations that starts flat, and as you rotate it around, it becomes a three-dimensional figure. And if we were to slice this, as in take slices this way, take a knife, cut through it, what would each slice be shaped like? It would be shaped like a very skinny cylinder. So, a circle, pretty much a circle with some thickness to it. So, there's a couple things we need to know. The area of a circle is pi r squared. But for an approximating cylinder, we have to do the area of the circle times the height of the cylinder, which we consider dx because it is the change in x, the thickness, which you'll understand a little more when I talk about it here in a moment. For example, it says find the volume of the solid obtained by rotating around the x-axis, the region under the curve y equals radical x from 0 to 1. We're talking about this section right here. And if you think about it, the distance from here to here is radical x, because that's our equation, and that's true everywhere. So the distance is radical x. Now, if we take it and we rotate it around the x-axis, we end up with a three-dimensional figure. And if we were to slice it, each slice would be a circle with some amount of thickness, a very small cylinder. And we think even further than that, each of these cylinders is going to have a radius. We, just like before, we were adding up the rectangles and doing the base times height, are going to need the integral of the area of a circle times its thickness. And if you notice, each of these discs have a thickness of x. So, dx, because, I'll go up a little bit earlier, a circle is pi r squared h, right? So pi r squared is the area of the circle. The h is the thickness, or it's an x thickness because our slices are xy. So in this case, we have these circles that are stacked from 0 to 1, because they start over here and they end at 1. And pi is in our equation. Our radius is, I'm going to grab another color, this distance, or this distance, or this distance. What expression represents that distance every single time, no matter which cut disk we're talking about? Well, it's radical x, because that's our equation. That's the distance from x to that function. And dx is our height. Now, from here, we can solve it. Pull our pi out front, because it's a constant. Square our radical x to get x. Anti-derive, which means we need 1/2 x squared from 0 to 1, which means we get pi times 1/2 minus pi times 0, which gives us 1/2 pi, or pi over 2. So know that when your region touches the item it's rotating around, slices of that will be a cylinder. We're going to run into some later this section that are slightly different, but slices of these are going to be a cylinder. Let's try another one. This one is slightly different because it says find the volume of the solid obtained by rotating the region bounded by y equals x cubed, y equals 8, and x equals 0 about the y-axis. This time we're rotating it about the y-axis. And y equals x cubed is this line. Line equals 8 is a horizontal line at 8. X equals 0 is a vertical line at 0. So we're talking about this section here that's going to be rotated. When we rotate it, we end up with an item that looks kind of like a bowl that doesn't hold anything. It's just rotated with no hole in the middle, so it's a solid object. This outside looks like a bowl. And the radius of each of these is going to have an equal value. So let's talk about this. We know we're going to need pi r squared because each one's a circle. Well, what's the thickness of each of these circles? It's a little bit different. If we talk about how thick each of these circles are, we're talking about a y. So we need to do this problem entirely in terms of y. And these circles are going to be stacked from down here to up here. So our limits of integration go from 0 to 8. Our pi, our radius, has to be in terms of y, which means we need to take this y equals x cubed and solve it for x. So x would be the cube root of y, and I'm going to put the cube root of y in for my r, because this distance is the cube root of y. In all situations, no matter where you draw the radius, it's the cube root of y minus the cube root of y minus 0, which is the cube root of y. So if we go on to solve this, 0 to 8, I'm going to move my pi out front. The constant can be moved out front. We get y to the 2/3 dy. Anti-derive. We get 3/5 y to the 5/3 from 0 to 8, which gives us pi times 3/5 times 8 to the 5/3 minus pi times 3/5 times 0 to the 5/3. This whole term is 0. 0 to anything is 0, times anything is 0. But this one, pi 3/5, if we cube root 8, because 5/3 power means to the 5th power and cube rooted, but we may do that in either order. So if we cube rooted, we get 2 to the 5th. Well, 2 to the 5th is 32, which means we end up with 96 at the top. The pi can go to the top, and the bottom is 5. So 96 pi over 5. Really look this over tonight. Come with questions tomorrow. Be prepared to work hard on these because this is the first step of several different kinds, and this is as easy as it gets. So make sure you really get a grasp on this before we move on to day 2.